In classical physics, the world of Newton, motion, gravity, and everyday objects, things make sense. If you throw a ball, you can predict where it will land. But when you step into the world of the very small, the world of atoms and subatomic particles, everything starts to behave in strange, almost magical ways. One of the strangest and most mind-bending ideas in this world is something called the observer effect in quantum physics. In the famous double-slit experiment, a particle like an electron or a photon is fired at a barrier with two slits. If no one is observing, or if no measurement is taken to determine which slit the particle goes through, instead, it acts like a wave, going through both slits at the same time. The result is an interference pattern on the screen behind the slits, just like water waves that collide and form patterns of peaks and valleys. But here's the shocking part: when you place a measuring device to observe which slit the particle goes through, suddenly, the particle acts like a regular object and goes through only one slit, not both. The interference pattern vanishes, and a simple two-line pattern appears instead. In other words, the act of observing changes the outcome. Somehow, the particle knows it's being watched and behaves differently. This is not a one-time glitch. It's been tested and repeated for decades, in labs around the world. A fancy term meaning that the particle chooses a single, definite state instead of existing in multiple possible ones at the same time. This strange idea raises enormous questions. Some scientists believe the measuring device itself disturbs the particle and forces it to make a choice. But others have suggested something even deeper, that human consciousness might be playing a role in shaping reality. This is highly controversial and not proven, but the mystery remains: why does observing something at the quantum level change what it is? In a version of the double-slit experiment called the delayed choice experiment, scientists delayed the decision to observe the particle until after it had already passed through the slits. Astonishingly, depending on whether they decided to measure it or not, the particle's past behavior changed, as if it retroactively made a choice based on future observation. Time, it seems, doesn't behave normally in the quantum world. So what does this all mean for us? At the most fundamental level, the universe seems to be made of things that only exist in a cloud of possibilities until we interact with them. Only when we observe them do they settle into one real state. You, me, your phone, the stars, we're all made of these particles. Which means that reality itself, deep down, is not solid and fixed the way we think it is. Imagine that the universe is a stage, and everything on it, particles, energy, matter, are actors. Without a viewer, the show doesn't exist. That's essentially what quantum physics suggests: observation creates reality. This isn't just abstract theory. It's been verified through countless experiments. Yet no one fully understands why it happens. Is it a physical process? A mathematical one? But quantum physics doesn't seem to agree. Now, imagine something as simple as a beam of light or the atoms in your body. Until they're observed, they exist in multiple states. When you interact with them, when you observe, they choose one. The rest of the possibilities vanish. In a way, the universe may only become real when it's looked at.